Hi guys, how are you? Week 9. I hope you had a great weekend. I have actually had a great week. A lot of weird things are happening, but we're here, right? Surviving and probably thriving. Now, the purpose of this video again is for me to go over what you submitted up to last night and then remind you what you have to submit until next week. And the third thing, of course, is to go over the material that we have for this week. Again, two more chapters, and you know, business as usual. Business as usual. So, concerning what you submitted, LO14, I saw three issues. One question was about the control group, about resistance training um, experiment, and a lot of you said resistance training, but in this case what we're trying to do is put something completely relevant in the control group, so because it was an attention control group, so reading would be appropriate. um, recruitment um, the recruitment approach is something um, that really affects, that's another item. The recruitment approach is something that really affects if the sample is representative of the population. Okay, and that's something that we really explained in the last video, but also it's, I think, pretty clear in your book as well. And then when we talk about selection and then the assignment, so when we're talking about sampling methods, the question was true or false if both must be random. It would be good if both were random, but not both of them must be random, because a lot of times it's impossible for both of them to be to be random. So at least when we randomize them, when we put them in the groups, so the assignment, at least the assignment in any case must be randomized. Okay, remember that. A lot of times the selection, it's impossible to happen, or for other factors we cannot do it. Okay, so again, it was a little bit of wording. I know a lot of you actually know the answers. I'm just trying to help you understand um, why was this, those were the correct answers. Again, it's wording. That wording comes from ACSM, and that will be the same um, wording that they would use in any of the exams. So if any of you goes towards taking any of those exams that they offer, that's the wording. Okay, and we should be familiar with that. Hello 15, excellent, great. I have no issues, so um, I'm good. No feedback for hello 15 other than you did great, I'm satisfied, and it's always awesome to see that you understand the material. Now, for um, this week, as you all know, you had LO 14 and LO 15 that I just covered, and you also had the city training. Okay, uh, if you submitted it, you get 50 points. If you didn't submit it, you get 0 points. There's nothing in between for this one. I went over and graded that assignment, and I sent you the feedback so you know. All right, and now for this week, week 9, as we're going into April, we have chapter 16, first analysis, and then we have database development. Okay, the first one, I admit, is a little bit technical, and it has to do with detection of enzymes. So it talks about first analysis of data that have to do with this kind of analysis. All right, we're going to talk about 3 different ways to do it. I don't want you to know a ton of information. I don't know if you're involved in something like that. If you are, if you will, then it will be more interesting to you. The second one applies to either to any kind of essays that you may do quantitative or qualitative. Okay, so I will stay there a little bit more. All right, so I'm going to start. I'm always using my notes because I don't want to forget something. With 16 first analysis after data collection, right? So as I said, this is a process in general and depends on the type of data you have. Now, if we have essays, right, and that's the main idea here, we have essays and we're looking to detect some enzymes from proteins and so on and so forth, then this is how we should go about it. There are a lot of different types of experiments here and how to do this. We're only going to talk about 3, but it will be, in my opinion, more than enough for the purposes of this course. Okay, essays. I mentioned essays. So that's a technique. Okay, and you can get a lot of information depending on whatever variable you're looking for. Our book talks about RIA, EIA, and ELISA. They're very different methods, but they're all detecting proteins. Okay, so we have the antibody, which is a protein, and then through that we're trying to recognize an antigen, which is pretty much a substance that could produce or produces an immune response. So those are the 3 we're going to talk about today. And then, except for those 3 that are all combined in one as essays, we're going to talk about the Western blotting, of course, and fluorescence microscopy. So those are the 3 different experiments we're going to talk about today. So again, RIA, EIA, and ELISA for now. Our book starts with the standard curves and the interpolation. Now, we have some samples with known amounts of protein, and those we'll call them standards. So then when we get our own samples, we can compare and contrast, and usually we get, for example, through ELISA, different shades of gray. So those variations of gray will show us if our sample has the same amount of protein as the standard sample, and so on and so forth. Then, based on that, we can use to create a curve, right, as you will see in our book. And why do we need a curve? The curve we need to create, so we need to have a model. We have a statistical model, and if you have a statistical model, then you can predict. Okay, and that's great. We have that example in our book from testosterone, about testosterone. But in general, what I want you to remember that lab notes are really important. They help us organize the data. We explain everything in our notes, but also they help us decide which kind of data we'll be actually using later on. All right, another issue, assessing accuracy and precision of your data. So except for standards, right, we talked about samples with known amounts of protein, we have quality control samples. Those are samples that are more complex and more unexpected results. But again, we can use them to validate the reliability of an experiment. Now, some steps we're going to have to figure out the variation of our samples. Again, we're talking about samples, okay? This kind of research. We're not talking, for example, about administering questionnaires right now. So we have coefficients of variation. We have the intra-assay, right? Coefficient of variation, 5 or less than 5% variation when we're running the same sample will made us feel good, right? That we have high variability, and we can rely on those samples. And then we have inter-assay, so we have different batches of samples that we compare with each other. Some other considerations, the database should be organized. As I said, the notebook documentation should be organized. The variability within the replicates in between assays should be good. Quality control, as we said, and then we have equations. At the end of the day, no matter what we do with that kind of samples, those first analysis, we need to be critical with one issue. What's practical? What's actually something that we see in the literature? What's normal? Okay, we always have to consider that. Now, let's go to Western blotting. All right, so more expensive procedure, but it gives way more information than ELISA. In general, we have the sample, we throw in some dye, and then through an electrical signal, we differentiate the proteins, okay? And then we transfer the proteins from that gel that we just created to membrane, and then we throw in the first wave on the antibodies and the second wave on antibodies, and then we can see through visualization and analyze the data. And visualization will help us a lot um, through, of course, looking at the intensity of the colors. Okay. Quality controls again in this procedure, as we said. Oh, and of course the whole steps, the whole 5 steps, you can see them better in figure 16.4. Now the quality controls. As I just mentioned, the Western blotting has a lot of steps. A lot of steps means a lot of higher probability of errors. So it's really important to get that purity of the samples, but to do it right, if that makes sense. Then we have positive control, that we can confirm that we are detecting the protein that we're interested in, and then we'll have negative control, that we're not detecting something that other than what we're interested in. Standardized protein ladder solution is solution of protein with known molecular weight. So again, with having that, we can compare to what the actual samples that we have, and again, we can do the standard curve, which is a procedure similar to what we just said before. And the last thing from that chapter, again, I don't want you to know a ton of information, just to have an idea depending on what you're interested in and what you're doing right now or you're interested in the future. Fluorescence microscopy, we can determine the location and presence of some specific proteins in the tissue. We can detect the changes of the levels of protein, the location, the intensity, and the quantity at specific sites. Again, positive and negative controls. And when we're comparing, it is important to have control and experimental groups within the same assay, so we can make those comparisons, or within the same experimental conditions, if that makes sense. One last thing about this is that we can adjust the filters of microscopy based on the background in order to get the results we would like to get based on our research. Okay. Again, 3 types of experiments. Make sure you understand that the notes are really important. A copy of the raw data is really important. Quality controls is really important, and maybe probably the most important thing is whatever you're getting after those first analysis is realistic. Okay. All right. Chapter 17, a little bit easier to digest, I think, for the majority of students based on my experiments, has to do with data development. Okay, and data development, database development is really important, as we will see. There's specific ways to store and access the data, and if you have a good and effective database, it will be easier to store, access, then analyze the data, and also security will be easier and more efficient. Okay, the whole chapter is around STOMP. Okay, it's a huge project that had to do with statins, and the authors of the chapter were involved in that, so they're using it as an example, which is, I think, a great way to actually show how these things can be applied. Let's talk about design and management of database. We can have quantitative data, as you know, well, numerals. Okay, we'll have numbers. Or we can have qualitative. What is your opinion about this? And it's an open-ended question. So different kind of type of data will require different kind of organization concerning your database, as you understand. Or you can have mixed methods. That's not, you can have mixed methods. It happens all the time. I'm actually analyzing mixed method data right now, which is like this. You can have close-ended questions, yes or no, multiple choice, like your type or like your whatever, and then you can have open-ended. And what do you do with that? How do you design your database to help you analyze both? Okay. Coding. That's another thing. The scheme that you're gonna use has to be selected before you even start collecting data. Okay. And maybe it's kind of easy to have quantitative. What about qualitative? How are you gonna code that? Okay. We're not gonna talk about qualitative research right now, but there's a thematic analysis and so on. So you have to kind of know where you're going, because if you do, then your database will be more efficient. You don't have to make a lot of changes. So the basic idea of the whole chapter, as you'll see, is it's better to be proactive than reactive. Now, if I had to interview 6 people, if I had to measure 6 people on the bike, that's easy. I use an Excel sheet, I'm good to go, right? What if I had 6,000, right? They're huge cohorts that you can do. For example, I know, for example, in California, Fitbit gave a lot of information to Stanford, right? We're talking about millions of people, and using Fitbit many days per week and in many occasions for many years. So we're talking about a huge amount of data. There, you need a more sophisticated organization. So our book talks about RedCap. You can go online and check it out. There are other ways to do it too. I've never used specifically RedCap. I use other ways to store data, but that's a good example. Now, the more variables you have, right, and not only the number, but also the type of the variables has to be something that will affect the way you design your database. So you need to be careful about that. As I said before, quant or qual, but also let's say you're just measuring VO2 max. Okay, cool. 100 people, 100 VO2 max scores. What if you were measuring 6, 7, like VO2 max, blood pressure, body weight, height, and then you wanted BMI, gender, physical activity level, age. Also, you had PARQ questionnaires, you had psychological questionnaires in there, and like you understand now that as we're expanding the variables, we need something more sophisticated. Now, plasticity of the database. 17.1, table 17.1 will be useful. Again, we'll have the Stomp example. We need to expect what the future may bring and be ready to add things or take things out or modify them a little bit. Excuse me. Again, that has to go with the experience, and or if you pilot study and see how it works, that could help a lot, right? So make sure your database or the database software you're using allows you to make changes, some of the changes that you would like at least. All right, let's talk about options for data entry, right? Excel, as I said, is great. Access is great. Not so technical. Expertise is required, so you use to do it. RedCap is web-based, right? So you can. The great thing about it is, I usually use Qualtrics, for example, but they usually like if you can have multiple sites that you can get data and upload them on the system. So that would be great. Now, the good thing about RedCap or Qualtrics is they give you ways to export the data based on where you're going to use it. Example, export a CSV file because you want to use it as SPSS, right? So you check SPSS and you use whatever, or CSV for Excel. Depends. We have SPSS, we have SAS, we have R, right? I use all 3 of them. So depending on what I'm gonna use the software later on for the analysis, I can export the data in a specific format, which is great. Security. A lot of times when we talk about security, we put that in the IRB proposal. You may have to put some in your proposal later on, your final project. So we have the data at rest and the data in motion. The data at rest is, let's say, I have hard copies of PARQ questionnaires, which I do, right? Where are they going to stay? For how long? Who has access? So I can say it will be my office Sibley 403C, or it can be the lab Sibley 323, whatever. I'm the only one who has a key. They're always locked in a file cabinet that I have the key only, and so on and so forth. So we need to say all these things. Now, when we're transmitting data, that's another thing. It would be great to have encryption end-to-end. Sometimes not, but a lot of times, you add a code, like even in an Excel sheet, you can add a password. So if I send you a file, if you don't have the password, you can open the file, and so on and so forth. Now, when we're collecting, and then we'll talk about entering. Well, let's start with collecting study data. SOP, standard operating procedures, usually called manuals, right? And they will explain pretty much everything we do, at least in a general perspective. And usually when we write them down, we develop them, and then we test them and we make some adjustments. They can be hard copies, they can be online, right? We'll have the source documents. It's very specific. It has to do a lot of time with every measurement and participant that we contact. What exactly do we do? Again, online or hard copies. A lot of time we'll have hard copies because we train their research assistants through them, and they do the same procedure whenever the client comes in. You greet them, you tell them to do that. You sit for 5 minutes, and then you take the blood pressure. Like, it is more specific. That's how you take blood pressure. Right? And then data entry. If I do something on paper, I have to then put it in some kind of electronic form, or I can collect it through an electronic form from the very beginning, as I said, through Qualtrics that I'm using a lot. Now, there are pros and cons in everything. If it's hard copy, a lot of times you can make notes and so on and so forth. And at the same time, though, when you're trying to import the data from hard copy to electronic, we may have errors. We will have errors, right? So we need to check again and again and again. So it takes time, and anything that increases error is not very good. At the same time, if we need to automatically add it electronically or import it electronically through Qualtrics, you may need to train a little bit the participant, right? You go there, you click on that link, and then let's say something happens to Qualtrics, and I lose my database. What's going to happen next? So again, there are pros and cons with hard copies or electronic format, but I personally use electronic. It's much easier for what I do. Accuracy, validity, and reliability. Somebody or some people have to repeatedly oversee data collection, and that has to be planned, right? And then not only the collection, but the entry as well. How? There's calibration that you can do, audit files, all forms should include data and initials, so we know what happened and by whom. Table 17.2 will give you more information. The thing is that there has to be some kind of overseeing all the time, especially if you have a lot of people and a lot of variables. Now, outliers. What are we doing with the outliers? What's an outlier in statistics, right? In simple words, is a number that's really far away from the mean of all the scores. So everything is around 5, and then you have 17. How did that happen? Right? Now, it could have happened because of an error, easy, like data entry, or even error on the equipment. We didn't calibrate the bike before, something went off. But also, we may have an extreme case. Somebody who's way better or way worse than the average person. In statistics, we have an issue with the outliers. We don't really like them because they mess up with our data. Okay? Should we remove outliers? It really depends. It really depends. It depends on what you're doing or how you can use them. A lot of times, based on why you collected an outlier, we choose to just not take them into consideration. Side note, a lot of qualitative researchers, they're so interested in outliers because they can go just interview that person, right, and figure out why you were an outlier. They create case studies. Anyway, that's another issue. Now, integrity issues. We may have missing data. right? Because we didn't import it, or we didn't, like, we asked them for 15 questions, they answered the first 10, and then the last 5 a lot of people didn't. What are we doing with that? How are we there are different ways. For example, there are software packages that can predict, right? Or we can just not take it into consideration. It really depends, again, how you can attack that issue. Let's say there's a difficulty retrieving information. Like, for example, now I'm trying to find something for my dissertation, right? To add it in a project. It's really hard for me, based on how I store that data, to retrieve it and find the raw data and find exactly what I'm looking for. So again, it goes back to database. I didn't do a great job. I didn't do a great job predicting how I would use this. And then maybe data transformed as we were moving them from one to file to the other, or from one computer to the other, or from one software to the other, or like for the example that we have in our book, like you may have from 2 decimals, you may want to 1 decimal, and then if you don't have the raw data, how are you going to go back and see if it's important for you to have 2 decimals, right? So those are integrity issues that we have to troubleshoot, and it's complicated, or it could be complicated sometimes. So again, as I said about myself, right, the initial design is really, really important, right? You have to talk with mentors and people until you get experienced enough to know what to expect, and then when you're experienced enough, you create better databases, more efficient. So different again, software, as I talked before, table 17.3. I usually use R or SPSS, but R is open source, which means you don't pay, and which also means that anybody can add a package, statistical package, if they want to. So everybody helps each other. It's really hard. There's a learning curve, really steep in the beginning to understand R, because you actually have to write the code. And you know how it is if you have ever written code. You miss a parenthesis, the whole thing is red, it doesn't work. So there are pros and the cons. SPSS, great. Click, 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 click. Do you really understand what you're doing though? That's the thing you do with R though, because you actually write the code, but it takes a lot of time. So there are pros and there are cons. There are things that R does better, and there are things that SPSS does better. Me personally, if I had to compare SPSS to another non-open source software, I would definitely prefer SAS, because it gives you more background of what you're doing. If you're asking me, okay, am I using SPSS? Yes, I do. Okay. But I've been trained in R. Now, other considerations: who will be in charge of overseeing? It's great to have a research technician, but that is we have economies of scale, so you can't use somebody unless you really use them and you have a huge project, right? So here, you need somebody experienced and expensive, but also you need somebody who understands the field, who understands the study, right? If you can't have somebody like that, then you have to cross-train different people to do this job. SOPs are really important. The third thing is we need to be flexible, as we said, to move the database in the long run from different sites to one, or different sites to other sites. And what about the availability? Who will have access to the data while we're doing the research, and after we do research, and even after we publish the research? For how long? And how much availability? Okay, are you gonna be able to see the names too, or just codes? Again, this chapter was a little bit more, I would say, applicable to more people's projects, so that's why I stayed a little bit longer. Make sure you understand the bullet points at the end, the glossary. The main idea is here that, as I said, being proactive is better than being reactive. And the bigger the project, the more we need to consider about the database. That's all for me for now. Everything is the same. I don't want you to worry about anybody and about anything. Again, our leadership is here. We're still working on anything you need. I'm trying to be on top of my emails, and email you back as soon as I get anything. I'll try to be as flexible as possible. But I'm not wearing a tie anymore, but other than this, I'm here. I'm working, and we're good. We're good. I want you to stay safe. And in the meantime, of course, I want you to lift intentionally, not habitually. Don't lose those gains because you have to stay home, okay? Try to be creative. Try to be creative. Bye, guys. That was it. I'll see you again next Monday. Again, stay safe.